Myself, I'm a self-proclaimed malware dev. I like to think that I can build stuff, but that's not always the case. And because we're a small company, shout out to me and my company, we do advisory, cyber, defense, offensive security products, you know, the good stuff. So what is today's goal? Today's goal is to hopefully leave you guys with a healthy dose of paranoia when it comes down to having PowerShell on your end users' workstations. How are we going to do that? Well, we're going to talk about like why you IT admins love PowerShell, why us attackers love PowerShell, and then a little bit about bypassing some organic controls, and then wrap it up with some malware deployment and how you can protect yourself. So, why do admins love it? Well, it's everywhere. It's on Windows, Linux, Mac. I have it on my Linux machine. I had it on my Mac when I had a Mac. Thank God I don't anymore. It's got a wide breadth of a market share. So it's very powerful and easy to use, which brings me to the next point. It's easy to use and learn. This is the first scripting language I ever learned, even before Python or C. It has so many resources and so many tutorials online that there's really no reason why you couldn't learn it in a couple months. And then lastly, it enables more functions around remote administration. So taking tasks down from hours to minutes. So why do attackers love it? It's everywhere, right? It's on Windows, Linux, Mac. I have it on my Kali machine right now. It's great. Easy to use and learn. Everybody likes to bash on Microsoft. Uh-oh, what did I do wrong? I'm sharing a wrong window. What am I sharing? Am I sharing like the... Oh, whoa. Look, God, this is terrible. Okay, how do I stop stream? Well, sorry, Twitch, you get to see me. Oh, yeah, you're right. Blame, yeah, Microsoft. Too many issues, too many problems. Should be good. Yeah. Are we solid? Thumbs up. Thanks, man. All right, cool. So again, why do attackers love it? Well, it's everywhere, right? Easy to use and learn. A lot of people like to bash on Microsoft, so they publish about it. Offensive cyber or offensive PowerShell scripting is probably one of the easiest things to look up. And remote functions, right? I don't need to use Impacket. I can use PowerShell. Simple as that. So when you start looking at it this way, the attackers really have the advantage. To put it bluntly, in over 95% of my engagements in the past, we've used PowerShell to gain code execution, privilege escalation, you name it, right? Some of the big advantages here are scripts can be run entirely from memory, right? If you have access to a terminal, you don't need to put it on disk. So with that, it makes it very difficult for antivirus systems to detect that activity, right? If they don't have a hook into what you're trying to call. It's scriptable .NET in the same way that Python is scriptable C. And organic functions are always getting defeated. So you can just do a quick Google search and find out what you want to beat and how to beat it. So let's get into the fun part, which is bypassing some organic controls. For the attackers in the room, you're going to roll your eyes at this, but I get a lot of times when my clients look at me and they go, "Oh, you can't run PowerShell scripts. Our signed script execution sets are restricted." And you're like, "Oh, okay, yeah." And so for most admins, when you look at this screen, this is what you see. You go to try to set your execution policy, which would try to change it, and it's going to go, "No, you need admin rights." For those who don't know, this is very simple to bypass. You just run PowerShell with TAC-EP bypass or execution policy bypass, and it runs it in that terminal. Microsoft has said on multiple occasions in their forums that this is not a security control, yet if you read their actual documentation on it, they write it as it is. So it's very easy to get confused. The reason why when you're trying to set execution policy in the PowerShell command prompt, you're trying to change the HKey local machine registry key, which requires admin privileges. But when you're just running a flag, it only changes it for that temporary instance. So if you exit out of PowerShell, then it's going to go back to restricted. You're not changing it for the whole machine. So the real stuff to bypass is Amze, right? The anti-malware scan interface. For those who don't know, Amze is a good known hook that they provide, or Microsoft provides to security what are they called? Applications like McAfee, Sophos, Kaspersky, Windows Defender, like duh on that. There's probably more. I really didn't research too much on who they hook into because they're not actively going out. But it has a lot of hooked in functions for Windows script hosts, the VB scripts, Office macros, the whole 9 yards. For PowerShell specifically, it blocks malicious scripts and functions. So you'll see a lot of times the IAX download string is a very common method to getting scripts into your environment that's blocked by Amze, as well as strings like Mimikatz, Bloodhound, PowerView, Matt Graber, you know, he'll get blocked all the time. So how can we bypass Amze? Well, there's another really, really easy method of doing this, which is just use PowerShell 2.0. In the interest of having backwards compatibility, Microsoft was like, oh yeah, this makes sense. Let's leave an old engine in there. To caveat though, you need .NET version 2.0. But if you run old applications in your environment that require .NET 3.5, .NET 2.0 comes with .NET 3.5. Uh-oh, what did I do wrong again? It's not showing the, I share, what the heck, man? All right, so we're gonna have a lot of technical difficulties apparently. Let's go back, let's stop sharing. I had a nice little like thumbs up and everything. You guys lied to me. All right, we're gonna do entire screen again. You guys can see everything. Maybe. Can I get a thumbs up from the man up top? Not yet. Yeah. I can't change the. How do I get out of this stupid presenter mode then? I don't use Microsoft products half the time. All right, guys, you can see how much I love Microsoft, right? All right, yeah, hit me up.
All right, we're gonna go like this. We're gonna make it. Can I minimize this stuff?
You can do whatever.
Check that out. That is awesome, I must say.
Inception.
All right, so we're gonna go like this. I'm gonna do something.
Oh, you're gonna mirror it, yeah. Display, or you're in the wrong section. Advanced display settings.
There we go.
This is mirrored.
We're gonna extend it. Sorry, everybody.
I'm not.
All right. So.
Sure. Oh, you closed out of the. Oh, are we in the wrong screen? No. Okay. Downloads. Return power. Oh God.
Okay.
Oh,
no,
wow. No, what do you mean?
No. Just presentation mode. Just hit presentation mode.
So skipping ahead, if you want to actually see what this looks like, it's very simple. The first thing that we're doing here is we're running PS version tables so that you can see it's running as PS version 5.1. It's not running 2.0. I'm echoing Amze utils. The reason being is now you give me PTSD. Every time you walk up here, I think I'm going to get in trouble. So if you try to call Amze utils, Amze doesn't like you trying to call itself, so it blocks you out. And that's a good way of testing to see if you've bypassed it or not. So when you run PowerShell.exe version 2, you can now call Amze. Another thing to note here is that if you don't run script block logging within your environment, when you disable Amze, it no longer creates an event ID for any sort of malicious or suspicious scripts. So as an attacker, that's really good for us. But if you don't have access to version 2, then you need to find a way of putting it into a failed state. The reason why we want to put Amze into a failed state is because Amze doesn't self-recover. So if you crash it, it stays crashed. So Matt Graber back in 2015 came up with this really cool reflective method where he just calls the function or the value Amze and it fails and then sets it to true. And that was enough to crash it, right? And that was back in 2015. Then up until about last year, you could concatenate the string like so, and it would still work, right? Thankfully, Microsoft fixed this, sorta. And I think this is a big standpoint to the talk, which is we started moving away from focusing on PowerShell because everybody started making C#, right? And because of that, we found other ways to bypass this. So the first thing that we needed to figure out whether Matt Graber's function still works, right? If we can reflectively call the items. Oh God, that is blurry. I'm so sorry for the people here. The first thing we're calling at the top of the screen is Amze utils. That's obviously going to get blocked. Then the next piece is us trying to concatenate the string to see if concatenation still works. Which it is, which means Amze still isn't doing what they promised, which is concatenating strings before execution. The next piece that we needed to figure out was exactly where is it getting blocked then. So we went as far as being able to call the field for Amze and it failed and printing out the information there. So technically you can still get to the area that you need to get to, which means Matt Graber's method still has a possibility of working. The fun thing is, and shout out to Secure This Shit because this guy has like a really good write-up on this, but it turns out that Amze is doing some regex. So when you do get type, get field, and then try to set value, then it concatenates the strings and goes, oh yeah, you're trying to call me, not cool. But the fun thing about Amze is rule number 1 when trying to defeat Amze, when in doubt, encode it out. Amze has no idea how to deal with this other than base 64. So in this example, I'm turning the text into hex. And when we're able to print it out, as we can see, it does come up as Amze utils and Amze and it failed. So we are able to call it without it blocking that information. And then the next piece is we need to turn the text into hex, right? So the hex into text and text into hex. So you get a nice little like Dr. Seuss rhyme, so you can remember that. That's fairly simple to do in a one-liner. You just split each individual hex code and convert it back into a character value. And it'll come out as Amze utils. So when you want this to run, oh, this will be interesting because now we're in a, oh, is it running? Cool, yeah. So call Amze utils to show you that it's actually functioning as Amze utils. I copy and paste in our Matt Graber method with the hex encoded text. And now we've bypassed Amze, right? Very simple, very easy to do. How do I go to the next slide? Oh God, it's gonna play again, isn't it? I think I froze my machine. Oh, cool. Here we go. Yeah, so then the next piece that we can talk about is Rossmouth. I know this looks like a lot of text. Don't copy it. Trust me, you can find it on Google a lot easier. But this is a really cool method because it's patching the live loaded DLL, right? So with that same kind of principle, you can bring in, or unhook EDRs, right? You can just reload the DLL if you wanted to with this same exact principle. The fun thing about this is actually just C# code written for PowerShell. They're using add type. I will recommend if you're an attacker not to ever use add type because it does leave an artifact on disk that is then scannable by antivirus. But for the purpose of this talk, it's very simple to use. Another thing to note here that when you're trying to break Amze in this method, you're trying to rewrite the first couple bytes in whatever function you're calling. The reason being is Amze has a static first 4 or first 5 bytes, which resolve to Amze. So if you can change that to anything else, it'll break Amze. And that has been around forever. And let's see if this actually is running. It is. Cool. Same idea, run Amze. I didn't make any modifications to this one. You can find it purely on Google, and once you copy it in, it doesn't alert. It runs perfectly fine. And when you go to call Amze again, it will call it. So you've bypassed it in 2 different methods here. And these are old methods, things that we should have been paying attention to back in 2015, 2016, let alone 2020 when we were all stuck at home doing nothing. But everybody was paying attention to C# or Go or Rust and all these other applications. So what do you do when you can't bypass Amze, right? What do you do when you can't call this code? Quite simply, you can just build your own PowerShell. And I'm not going to go too much into the code on this one, so I just wanted to shout it out and show you guys that it is possible. You got to think of PowerShell as basically a bunch of DLLs loaded on top of command prompt, and that makes it a PowerShell, right? It makes sense when you look at it that way. So the first one, or the demo that I'm going to show you here is from MSBuildShell. MSBuildShell is using the .NET 4.0 MSBuild.exe, which is a living off the land binary provided by default in .NET version 4.0. This can be found on that GitHub page. I have dropped this on disk on so many red teams that I can't even count them, right? But it's very, very easy to do. You call the direct MSBuild.exe and then your CS project file, and did it stop running? It did. Then it should execute into this fancy little fake PowerShell, right? But it's got the exact same functions of PowerShell. The only thing you don't get is tab completion, but we never left the command prompt, right? But this is just something to shout out because it is very easy. A lot of people forget about living off the land binaries. There are plenty of ways to load in different DLLs that will just load PowerShell, right? Here's some more ways to do it. PowerShell DLL project. You can run DLLs in multiple different fashions. My ultimate favorite when it comes down to creating my own PowerShell is using the Sync App Publishing Server. This one's pretty fun because it's a reverse PowerShell. So if you use Netcat on your host, you can catch this this callback, and then you got a nice little PowerShell shell from your Kali Linux machine. If you guys want to know more about this kind of stuff, look at Red Team for their write-ups. They're pretty solid. Holy crap! I realize I'm like zooming through this bad boy right now, but I think we're behind time, so that's okay. So here's the fun part. This is what everybody likes to talk about with me when it comes down to offensive PowerShell. So as I mentioned before, PowerShell is just .NET scriptable, right? And that allows you to write C# code for PowerShell and vice versa, which is why we saw such a huge boom coming from what was it called? Coming from PowerShell over to C#, like Sharphound and all those other things. If we want to run our own malware, and this is kind of outside, but if you want to run your own malware, you need a few libraries or functions. The first two functions are virtualalloc and create thread. Those come from the kernel32.dll. And the last piece you need is really the Marshal service to copy. Additionally, even though we don't put anything on disk here, we still need to avoid antivirus detection. And we can do this by reflectively calling our DLLs, as well as some shellcode obfuscation from within PowerShell. So for the first part, which is importing our code, that's very, very easy. In the top example here, the DLL import, that's on pinvoke.net, that's C#. The one right below it is using Matt Graber's reflective method. There's a few other methods. Offensive Security built one as well, which is really long and complex to read. So I use this one as a good example. But as you can see, they're very, very similar in the way that you would import them. And then when you call them, they're equally the same. The only difference here is the first example of virtualalloc, that comes from C#. Use a period instead of 2 colons. And when you're doing it in PowerShell, you call the type name that you created and then int pointer : : But if you can write C#, you can write it for PowerShell, which means that you don't actually have to have anything ever touch disk, which is great. The second piece comes down to shellcode obfuscation, and this is still pretty necessary. The nice thing about PowerShell, though, is it reads bytecode in decimal instead of hex. So 0x00 becomes 000 and 0xff becomes 255. I don't know. I don't know if it's the same for everybody here, but for me, it's like if you can just see those numbers, it's like, okay, cool. Don't go over 256. Got it. So for shellcode obfuscation, you don't have to do anything fancy. You know, you don't have to write your own encryption method or anything like that. You can do an XOR and a Caesar cipher. In this example, we'll just talk about using Caesar ciphers. That's pushing your bytes to the right or to the left in any number of order. So 000 would become 005 if we have a Caesar cipher of +5. But in this case, also 255 becomes 260, which is a problem. So another great operator that PowerShell gives you is modulus, which is just the %sign. So if you ever need to use modulus for your shellcode obfuscation, that's exactly how you do it. Just 256 minus your offset or plus your offset, whatever way you're going, and then modulus that by 256. And that will make 005 become 004. So, you know, with all that, it's very simple to create your own malware and obfuscate your own malware from within PowerShell, right? There's not a whole lot of difficulty when it comes down to this. So what does that look like? In this example, I'm showing the full screen so you guys can see it, but I'm running a Meterpreter reverse HTTPS handler that we've created the shellcode beforehand. One thing to notice ahead of time, which it sucks that this is so small, but the process that we're running in for PowerShell is 11496. And that Amze is indeed running in this case, right? I haven't gone and defeated this at all. The next piece that I kind of want to shout out here, which also kind of sucks that this is kind of blurry, is we've talked a lot about copy and pasting things into the terminal. When you're running your own kind of management shell or script from PowerShell, like PowerShell Empire or something like that, we can't use IEX download anymore because too many people have abused that. So fun fact is you can just use the .NET web request function, you know, scriptable.net, and you can load whatever PS1 file you want into a variable and then execute IEX against that variable, and it will load in your malicious script. So that's what this little piece here is doing. It's reading the data stream into a .NET IO stream reader and then loading that into a variable that will then execute. So in this case, it's bsides.ps1 that we're calling from. I copy IEX content, drop that in, and now we can call invoke bsides, which is our malicious payload. Input the offset here. As you'll notice, there is no pop-up. Antivirus didn't discover it. Amze doesn't care for it. And when we jump back over to our Kali Linux machine, we've executed a shell, a full Meterpreter shell, mind you. So if we get UID, we can see that this is a low privilege user. And then if we get the PID, it's 11496, right? So this should be a little concerning in itself, right? It's 2021. We can still run really simple shellcode execution methods without detection. Now, of course, if you were to use something a little bit more advanced than like Windows Defender or other static-based analysis, you're more likely to capture it. But with your obfuscation techniques that you implement here, it's still fairly easy to bypass. So yeah, I don't know. Now that you're paranoid, hopefully, what can you do about this? My first example or thing, disable PowerShell, please. Like I can sit here and beg against you guys all day. You wouldn't give your users Python, would you? So like if you don't have a use case, why would you give your users PowerShell? It's the same danger. If you can't disable PowerShell, maybe expand out your application blacklisting. Not everything Microsoft gives you is actually safe. I don't know if you guys remember DDE Auto, but that was pretty dangerous, and they just claimed it was a feature. Use some AI-based security products. This one's a big one. The reason why I say AI-based security products is if you're able to unhook a DLL, like we had mentioned with the Rossmouth method, a AI-based security product will alert that a bypass is occurring, right? A sensor bypass. So it has ways of telling that it's still loaded into a process memory. And the last one is a little less for everybody here, but Microsoft kind of needs to fix their stuff. It's 2021, right? There's a lot of 2015 methods, not just the stuff that we talked about here, especially because it's only a 30-minute talk. but there are a lot of methods that still work today that worked back in 2015, 2012, even as far back as 2008 when it was first released. And that's just because Microsoft likes to have backwards compatibility. So they still have a lot of inherent flaws in that regard. But with all that, this is who I was and who I am. I know this was kind of a hectic speech. A lot of errors came up, so I apologize for that. But I will open it up to any questions anybody may have, or comments, concerns. Anybody else want to shit on Microsoft for 5 minutes? None? Sweet. So that's my talk. Thanks for the time, Mo, and hope you have a good B-sides.